Hello, welcome to another Masterclass by To70. Today we'll be talking about fast time simulation. At To70, we have been using fast time simulation for over 15 years in numerous airspace and airport projects. We believe fast time simulation is a very powerful tool that can support decision-making processes by providing objective data about planned developments and new ideas. These can range from new concepts of operations, airspace redesign, construction or maintenance of airport infrastructure, test capacity for forecasted traffic, and so on. With fast time simulation, the effects of each potential change within the airport or airspace can be quickly visualized and analyzed. What we have seen in our international experience is that there is a need of many aviation stakeholders of obtaining objective data, both quantitative and qualitative, before investing resources and time into planned developments. These decisions used to be based on expert judgment, but nowadays more sophisticated analysis is possible thanks to fast time simulation, among other tools. This does not mean that expert judgment ought to be disregarded. In fact, expert judgment is an important element when building the simulation model and analyzing the output of the simulation. Fast time simulation enhances old assessment methods by providing unbiased information. No matter what fast time simulation tool is used, in our experience, any fast time simulation project will follow a similar process. First, the project is initiated with a kickoff meeting, during which the project objectives, deliverables, and key performance indicators, or KPIs, must be described in detail and agreed upon. It is at this stage of the project where all the expectations must be understood, and everyone around the table should be informed about the possibilities and limitations of fast time simulation. The possibilities are almost unlimited, but there are some things to keep in mind when running a fast time simulation project. For example, one has to be aware that the output of the simulation will only be as good as the input provided. As they say, garbage in, garbage out. During the input phase, the input for modeling the airport or airspace is gathered and processed. Inputs can come from different sources, such as the AIP, interviews with operational experts, on-site data gathering, historical traffic data, and so on. It is recommended to use georeference data so as to instill accuracy into the simulation model. When all the inputs are processed, the baseline model can be built. This phase is critical, and the objective is to have a simulation model that resembles current real-life operations as much as possible. For the example shown in the animation, which is an airport simulation, elements like gate allocation, pushback procedures, taxi flows on the ground, runway dependencies, separation minima, runway queuing, and sequencing need to be understood and modeled with care and precision. Once the baseline model is ready, the validation simulation can be run, and the output data can be obtained. The output of the simulation, both quantitative and qualitative, will then be checked by the operational experts. They will, for instance, look at simulation replays, like the one that can be seen here, to check whether the simulation behaves as they expect real operations to. Strange behaviors will be apparent to the operational expert, and with their feedback, the simulation model can be further tuned so that it behaves closer to reality. For the quantitative validation, the results produced by the simulation are compared against actual data. For instance, 1 or 2 days of actual traffic is selected, and a set of KPIs is defined, by means of which comparisons will be done. The discrepancies are analyzed, and if they are considered to be too large, further iterations of this process will be carried out. In each iteration of the process, the received feedback is implemented until the best possible match with reality is achieved. This process will never be exact, as there's a lot of unpredictability in real-life operations, such as human error, weather, strikes, and despite the ability of modeling these events to a certain extent, it is important not to focus on the specific values but the overall trends. Once the baseline model is validated and considered fit for purpose, new models reflecting a number of future scenarios can be implemented by making modifications to the baseline model. Thus, any difference found in the results can be easily compared to the current situation, meaning the baseline model. During this phase of the project, good communication and documentation are needed so that the team can work efficiently without overlapping or stepping on each other's work. Tools such as Git, or any kind of code version control, are very useful in this stage of the process, as they allow to keep track of the changes made, as well as going back in time in order to fix mistakes, or even redefine a scenario. When all the different models are ready, the simulation runs can be started and you can sit and relax and go over coffee. Once finished, the output of the simulation is processed and presented in the best possible way. This depends on the KPIs and type of information obtained, such as tables, graphs, heat maps, simulation replays. Ideally, all the KPIs are shown in a dashboard so that the results can be analysed by our experts and presented to the stakeholders from different perspectives and at different levels of detail. And that is, in short, how a fast time simulation project runs. If you require more information, please don't hesitate to contact us. You can find us on LinkedIn, Twitter, and at our webpage at To70.com. We will be happy to hear from you. Thank you and have a nice day.